Thanks for coming. I'm Josh Moore. I'm here with National Instruments AWR, and I'm presenting with Nebabie from Cadence. And this is our simplest slide. If everyone could please take the time to read this, that'd be great. No, actually, this is just the abstract from the presentation. Let me summarize for you. We're going to talk about how our two tools work together. We're trying to make it easier and easier for designers to focus on getting their design done and not focus on moving data between tools. So when we talk about flows, AWR, we make a nice simulation tool, and Cadence makes fantastic manufacturing tools. There's really two kinds of flows that we hear about a lot. The first is a verification flow, and that's where you have a bunch of data in your manufacturing tool. It could be Allegro, it could be Virtuoso, but you want to bring this data that's ready to go to manufacturing into a simulation tool like AWR and make sure that all the RF still works, since RF can be a little sensitive to things going around it. Similarly, we have customers ask about what we call a manufacturing flow, and that's where you start a design, the RF section of a design inside of AWR, and ultimately that design has to go into some manufacturing tool. It could be IC, it could be PCB, so it could go to Virtuoso or Allegro, but you want to get the RF section in there and then finish off the rest of the chip. So if you look at a block diagram of the IC verification flow in particular, we can read GDS out of Cadence Virtuoso. It comes into our environment, we import it, and then we can simulate it in either a 3D planar or a 3D FEM simulation engines. And then we take the S parameters back out, back into Cadence for the final chip verification with the parasitic extraction and the axiom models.
Okay, so what's shown here is the Virtuoso environment, the Virtuoso design environment. And on the left side, you see the schematic flow. On the right side is the implementation flow. So as Josh said, we feed in, basically, well, first of all, you start off with a design entry, capture your design, go through a pre-layout simulation with an estimated parasitic, and then after you do some design centering, then you do the implementation flow. At this point, once you go through the placement and routing, you have physical data that you can extract using the Virtuoso environment. But then for those high frequency designs that need accuracy, that's where we feed that data structure, or I should say the physical structure, into the AWR environment, which is Axiom, and run a 3D solver to extract the S parameter model and then feed that into a post-layout RF simulation step, okay? Okay, oops. So when you feed that post-layout RF simulation step, what you see here is an example design that we did that for. And so this design consists of, a lot of other structures, but it includes two inductors. So that step that I showed you earlier, we'll be feeding in an inductor physical structure into the AWR environment to do the 3D simulation, bring that back in here, do extraction of the entire design. This particular design where we demonstrated this flow is a power amplifier, okay, that was implemented on a MMIC die using Virtuoso tools.
Okay, so here you can see, she mentioned the two inductors. Those were really RF critical portions of this design. So we brought them into AWR, put some ports on them, and simulated them in the EM engine to make sure that indeed they were inductors, they were the right kind of inductors. I treated them as two separate things. There was a lot of space between them, there was a lot of metal between them, but we could just as easily have had one structure where we looked at any coupling that was going on between these inductors as well. One of the really nice things about our EM environment, and this is not specific to the simulator, that's something that's handled in the UI, is this automatic shape defeaturing that we have. This means different things for PCB. In PCB, it could mean converting circular vias to hexagons or octagons or squares. In a GaAs IC or GaN IC, it could mean converting like I-beam metal stacks into just straight up and down metal stacks. But in RFIC, we always have a problem with the vias. There's a ton of them. And a ton of vias means a ton of mesh cells means a slow sim. So when it's appropriate from an accuracy perspective, the automatic defeaturing you can see from the top picture to the bottom picture can convert a ton of little vias, the via array, into just one big square via. You get a dramatically simplified mesh, and you get a huge simulation time saving as a result. Slide came back.
Okay.
So moving on to the next bit, that was the verification flow for IC design. It's very similar for PCB, that we can take the data from the PCB data from Cadence Allegro, bring it into our environment and simulate it. The difference is instead of using GDS, we're using a different file format called 3DI. And before we get into some of those details, Nebabie is going to talk about Allegro for a second.
Yeah, so this is kind of to give you a snapshot of what a manufacturing flow would look like. So for a PCB design, we have the core of the circuit, but then when a designer wants to bring in an RF module, they're easily able to bring it into the Allegro environment using the analog RF option that's built on top of Allegro. But basically, you can bring the physical structure there, do some authoring, and then do an extraction on the entire design at the PCB level, do simulation, and move on into manufacturing, generate the physical data for manufacturing. So this is the complete flow, and we're providing front to back, basically automation from capturing the design, authoring, to extraction and simulation using the Allegro flow. So it is the de facto manufacturing flow that our customers are currently using. Okay. Go ahead.
You're next, too.
I'm next. Okay, so I talked about the manufacturing flow. So the way we demonstrated this particular flow is using, again, a design, which is a diplexer, 1.5 gigahertz. You can see here the physical structure in Allegro. And the top part is showing the transmitter, and the bottom is the receiver. And this whole flow is demonstrated using this particular design. And it's available to our customers, mutually between AWR and Cadence.
So something that's hard to see on this slide, really impossible, is on the top of Allegro there's a little menu pick that says AWR, and under that menu it says send this design to AWR. And if you do that, this is what you get. So you can see in the bottom right, the whole design comes in, all the layers, all the vias, all the shapes. In this particular case, it's a 6-layer board. There's two really, really perfect ground planes between the top and the bottom. So I separated out the top and the bottom. You can see each of the EM analysis set up in the top left and the bottom left there. And the analysis, the results, of course, show that it's a diplexer and it's doing all the things you'd expect. One of them is passing something and the other is rejecting that same thing. Another feature of the EM engine that was used, in particular the Axiom 3D planar engine, is all the automatic port setup that it offers. So in this case, all I had to do was place the ports on the edge of my structure, and then the ports are intelligent enough to back themselves up a little bit, make sure that the right waveform is actually going through the structure at the place where I put the port, and also connect itself to ground planes, so you have really nice ground references, and you know that things are going to be really accurate. So in the very beginning, I mentioned there's two kinds of flows. We have the verification flows, and we have the manufacturing flows. Just a reminder that this is what a manufacturing flow looks like at the block diagram level. You start an RF microwave design in AWR, and then through a series of intermediate files, and this is different for RF and for PCB, or I'm sorry, for IC and PCB, you send the schematic and layout from AWR into the Cadence design environment. Unfortunately, it's a 10-minute presentation, and so we don't have a whole bunch of follow-up material to show you at this presentation, but if you came by either of our booths, we'd be happy to talk to you about the manufacturing flows that we offer. So really in summary, there's two kinds of things people want to do, right? Get data from their manufacturing tools into a simulator, or start a design in an RF simulator and move them into manufacturing tools. It doesn't matter if you're doing IC or PCB. The way we're working together with Cadence, it supports either. And the point of all this is always the same. Engineers use both these tools today, and we want them to be really focused on the engineering and not so focused on driving tools and manually translating data and all of that kind of stuff. So that's really it. For more data, or to talk in detail about any of this, please come by and see us. National Instruments, AWR is just right over there in booth 633. And Cadence is right next door to us
across
in 840.
Okay.
Any questions? We're done.
Any questions? Clear as mud?
Thank
Okay.
you.
Thank you.